go, Bob. So we have 8.3, the product and quotient theorems for complex numbers. So the product theorem, don't write. Don't come for me because you're gonna be mad if you write it. The product theorem is basically stating that if you are adding, multiplying what we did yesterday, well, not yesterday, but the day before, our complex numbers, with trig, what is that? What are you doing mathematically? Well, it comes down to be you are multiplying your radicals together, their radiuses, the radii, the correct way of saying that. You multiply the radii, and then you're gonna find the sine and cosine of the combined angle. Okay, so you'll be given two different values, and you're gonna find the sine and cosine of the combined angle. So exactly what we were doing in 8.2, you just now have two angles that are being multiplied, two vectors that are being multiplied together. Does that make sense? All right, so in shorthand, this is what it would look like if you were to write it. This is the rule you're following.
So write this.
Yes.
The compact form?
The compact. Okay. So again, it's just a formula, and we just plug in information and evaluate. Easy enough? All right, ready? So it says, find the product of 3 cosine 45 degrees plus I sine of 45 degrees and 2 cosine of 135 degrees plus I sine of 135 degrees. So first, let's just identify. We know that our R1 equals 3 and our R2 equals 2. Agree? We know that our theta 1 equals 45, and we know that theta 2 equals 135. Agreed? And now all we're going to do is plug it in. Plug it in, plug it in. Okay, so we plug in everything where it goes. So notice here, this is the plug-in part. This is what you're writing down. So we have R1 times R2, and then the cosine of our sum of our angles plus I sine the sum of our angles. And now we're going to evaluate. What is 45 plus 135, my geniuses? 180. What's 3 times 2? So now we're down to 6 cosine of 180. Sine of 180. Do we know those values? We do. What's the cosine of 180? -1. What's the sine of 180? 0. Yes. Woohoo! So smart. So proud of y'all. And so simplify. What do we get? What's our final answer? -6.
You wouldn't give us no chance.
What? I'm sitting there writing down.
You love the answer.
Well, they answered me. I clicked and said people answered. You told me to try to get both in, so now you want me to slow down. Got it. Y'all heard her. Recording. Okay, so we identified our R1 and R2, our theta 1 and our theta 2. Yes? Then we plug them into the equation. R1 times R2 times the cosine of theta 1 plus theta 2 plus I sine of theta 1 plus theta 2. Yes? Yes. And then we simplify, and we got down to 6 cosine of 180, I sine of 180. And then we evaluate it. What's the cosine of 180? -1. What's the sine of 180? 0. We add, we multiply, and we got our final answer of 6.
Where'd the I go? Oh,
Wait.
I times 0.
I times 0. Yeah? Yeah. Doable? All right, let's talk about the quotient theorem. What happens when you're dividing them? If you guess, that means you're subtracting. You're so smart. This is the part. When you're dividing, this is the expanded, and then, or you can write the condensed, which would look like that. So you can write the expanded or the condensed form. Huh? You choose the condensed.
Really? Let's see here. I'm writing notes.
So here's your quotient theorem. So product, we were doing what? With the angles? Adding. With quotient, we're doing what?
Dividing.
Dividing. Got it, Bob.
You would think it'd be all on some equation.
Because it's asking you to multiply and divide the two. We already did some already, remember? So it's on 8.2. Yes, I could try to do 8.5 day, be done. Huh? Is it long? It is a long one. I don't care. 8.5 is not.
What do you think that is?
But we're almost done with this.
I know, so I said, this one was pretty bad. I just don't want to rush over 5. Okay. I would rather do 8.5 on Monday, review on, have the work day on Wednesday, then take our test on Thursday or Friday.
I think what the class about the week.
Our chapter 7, chapter 8 tests.
Oh,
You still have your final the following week.
I'm not thinking it. So like, if we did 8.5 today, you pick our unit today.
Yeah, it's scheduled for Wednesday. But 8.5, 8.5 is a lot. It's about graphing. And I think we should finish 8.3, give you time to work on your assignments, and then we'll do 8.5 on Monday. Just to be fine. Take the test on Friday. All right. Are you ready? Now we're going to apply our rule. So it says find the quotient. So we have 10 cosine of -60 plus imaginary sine of -60 degrees divided by 5 times the cosine of 150 plus I sine of 150. Okay, so we're gonna identify your R1 and R2. What's R1? 10. It's gonna write it here. R1 equals 10. R2 equals 5. My theta 1 is -60. I don't know why I wrote a Q. My theta 2 is 150. If the -60 bothers you, what could you change it to? And work it that way, but we can do it with -60. All right, are you ready to plug everything in? So we're gonna plug everything in, and this time it's gonna be our R1 divided by R2, right? I mean, R2 divided by R1. That's it, right? R1 divided by R2, and then we're subtracting. Huh? Yeah.
is there like a difference?
No, I'm just lazy. Nope. All right, so we're gonna simplify what is 10 divided by 5. Do y'all need me to write it in expanded form, or are we okay with the condensed? All right, so 10 divided by 5 is gonna give us 2, and -60 minus 150 is gonna give us what? -210. So we're now down to this. Okay, so we're asking ourselves, what is the cosine and sine at -210? So we know that if we're looking for the cosine of -210, it's the same as what? Where's positive? Where's -210? Is what? 150. So if I'm looking for cosine of -210, it's the same thing as cosine of 150. So I need the cosine of 150 and the sine of 150. Does that make sense? So we found its coterminal. How do we find the coterminal? We add 360, correct? Are we good? So when I look at my unit circle for cosine and sine, I'm going to get these values. Agree? Thought I wrote sine, sorry. And that's because I look at one cosine of 150, sine of 150. The cosine of 150 is negative square root 3/2. And the sine of 150 is 1/2. Now I'm going to distribute my 2. So we distribute the 2. Everyone gets a 2. And what does that do to, basically? It gets rid of the halves, right? So our denominators are gone. So our final answer is square root of 3 plus I. How do we feel about quotient?
Is it always gonna be in that form where it's like
It may use words. Like the first one we had words, right? It said to find the product. So it may say find the quotient of blah, 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 blah. All right, our last one's gonna be when it's not on the unit circle. What do we do? What you say? Oh, you're fine. I was just saying our last example.
Calculated and not calculated part.
No. Let's keep
Okay.
going.
It should be calculated.
Thanks. You're welcome, but still not using your unit circle.
Or can I use my take our own unit circle?
I mean, if you want to use your class time to make your tip. That's all. Did I say that?
You did say that.
You said you didn't.
Yeah.
Fine. I thought we were talking about the final. On the final, I don't care if you use your unit circle. I didn't know we were referring to the test, but whatever. If it's gonna make a big difference. If it's gonna make a big difference. Here we go. Are you ready? Am I good? Example 3? All right. So example 3, it says to use a calculator to find the following. So we're going to be calculating our non-unit circle values. So if I'm finding this before I put it in the calculator, I want to condense it as much as I can. Does that make sense? So the goal is before putting in the calculator is to condense it. So you're still going to have your R1, your theta 1, your R2, and your theta 2. And because I'm finding the product, I'm multiplying. I know that I'm multiplying my radii, and I'm adding my angles. Agree? Because its product is multiplying, we're multiplying our radii, and we're adding our angles. Okay? So that's what that's going to look like. In all honesty, at this point, you can just type this entire thing. No, but you can't because of the I. Dang it, that darn I. If the I wasn't there, we could go straight to the calculator. However, the I is present. And so the calculator is not going to read the imaginary, so we have to do it in parts. Okay. Obviously, we can do our radii, right? 9.3 times 2.7. And we can add. But we're going to have to do our cosine and our sine separately. Does that make sense? So we're going to have to find the cosine of 175 and the sine of 175 separately. So that's what we're putting into the handy dandy calculator. Let me grab old Sylvie. Hello, Sylvie. I'm going to reset her because I don't know what I do. Second plus 712. And I am in degree mode, so I need to make sure mode. I'm going to go to degree. And now I'm ready to find my cosine of 175 and my sine of 175. So cosine 175. Hit enter. Oh, And then I'm gonna find my sine of 175. I'm gonna make it round to the 3. So I'm gonna go back to float. Oh, I really need a mouse up here. All right, and then I plug in. Okay, so I have those values. And what you're gonna do is in the calculator, you're gonna do the multiplication. So I'm gonna show you how to do the multiplication. You're gonna do your 25.1, 25 and 1100ths times. And the best thing to do is in your calculator to go up to that value. Does that make sense? To go up to the actual value or either one of these. So I'm gonna go up to the value. I'm gonna click on it. And I'm gonna let the calculator like math it out for me. Okay. If it's not rounded and you want to be more exact, I would do 25 times, and I would go up to the longer one. And it would be the same thing. Well, it's off a little bit. I don't know which one they're going to want on Desmos. Maybe Desmos wants you not to round to the very end. Let's assume that. Not Desmos. My lab. Wrong class. Wrong class. This is what happens when you teach 3 different classes, guys. Things you never do. Not Desmos. My lab may not want you to round into the very end. Okay. So if you're like, I did it all right. Well, it may just say it doesn't want you to round to the very end. All right, 25.1. Again, I'm going to do times. I'm going to arrow up. Grab the longer one, just in case. Hit enter. And notice I'm doing the complete math process in the calculator to get the most exact value I can. Does that make sense? All right. So then now I have everything. And it's going to come down to those values. How do we feel about calculator? Okay. The key thing is that you're finding the cosine and sine separately, and then you're going to multiply those values by the multiplied radii. That's your final answer. The final answer is approximately that kind of thing. Yay, nay. All right, we're going to do a quotient example, and then that's it. Put my mode back. Whoop, whoop, whoop. Okay. The goal is when you're taking notes, if you start understanding something, remember always just try to work ahead. So like if you were like, oh, I know what I'm doing, the goal is for you to try to just keep going ahead. Okay. All right. Woo, pretty. So now we're finding a quotient. Do we have a C part? No. That's the last piece of our notes. Okay, because it's quotient, what are we doing with our angles and our radii? We're subtracting the angles and we are dividing the radii. R1 divided by R2. Okay, are you ready? Almost, got it. All right, so we're gonna set up. So we're gonna identify what we're doing. So we said we were gonna divide R1 divided by R2. And then we're subtracting theta 1 minus theta 2. Okay, we're going to simplify at this point. So in order to simplify, you're going to divide the radii and subtract your angles. It gives us 15 minus 4, which is 11 pi over 20. Right. Quick little cross chopsticks in the bowl to figure out my subtraction. In case you're wondering what I did. 3 times 5 is 15. 4 times 1 is. And 15 minus 4 is 15 minus 4 is 11. And then you multiply. 4 times 5 is 20. So when we condense, it becomes 11 pi over 20 and 2. Not with the pi. You can put the fractions, just don't put fractions with the pi.
So what is two minus 1 over 5?
Mm-hmm. It's gonna give you, yeah. Or you could just, cross multiply and subtract.
I don't understand.
Tell me why.
It just doesn't work for me. There's no problem.
Okay, really quick. I am more than glad to make sure that makes sense because it'll save you some time in life in general. If I have 3/4 minus 1/5, you cross multiply, and that gives me 15 minus cross multiply 4 all over the bowl, which gives us 11 over 20. Chopsticks in a bowl. You wanted to be harder, didn't you? All right. Now, at this point, what do I have to do? I have to find the cosine and sine. So I'm going to go to Handy Dandy Sylvie, pull her up. Yes. You have to include your pi. I should have reset. Second plus 712. I can go back. Now I'm in radian mode, right? Which is auto default. So I'm going to find the cosine of 11 pi divided by 20. Hit enter. And I'm going to find the sine of 11 pi divided by 20. And hit enter. Okay. Once I have those, I'm going to have to do what with the 2 to each one of them? Multiply. So I have to distribute the 2. So we have 2 times. I'm going to just go arrow up and grab it by pressing enter. And there's my first term coefficient, my constant. And we're going to do 2 times the sine of 11 pi. And that's my imaginary. You did? You sure?
She is the divide.
Nothing's wrong with the divide thing. I do the divide thing.
She needs the parentheses, right?
No. It'll do the math first. It'll multiply and then divide. There's only one term in each denominator. In the numerator and denominator. I didn't make it do it again. Remember I said you gotta make sure you're in radians. All right, so my final answer. And that is 8.3. How'd it feel? Doable? All right, I surely can.